Let's discuss the question number 28 from test 3, and it is from solid mechanics. Okay, so a hollow shaft, the outside diameter of a hollow shaft is given whose outside diameter, let's say D, is twice its inside diameter. So this is basically your D by 2. Okay, and the ratio of its torque carrying capacity to that of a solid shaft of the same material and the same outside diameter. So you have a solid shaft which has the same outside diameter as which has the same diameter as the outside diameter of the hollow shaft. Okay, so in both cases we are asked to compare the torque carrying capacity. So suppose it is twisted by both are in twisting. So let's use the torsion equation. E by J is equal to tau by R. Okay, now suppose I apply, so what is torque carrying capacity? So torque carrying capacity is the maximum torque a shaft can be twisted with. A maximum torque you can apply on shaft until the stress reaches the yield value, or the maximum, or whatever your criteria based on FOS is there. So reaches the maximum yield value. Okay, so now because they are made of the same material, they will have the same yield value. Both will have the same yield value. So this, when it reaches the maximum or the yield value, then my T is called the torque carrying capacity. So let's apply this torsion equation both for the hollow shaft and for the solid shaft. Okay, so for the hollow, let's T be the case for the hollow, maximum torque carrying capacity for the hollow. J is my the polar section modulus, which is in this case is written as pi by 32 into d power 4, the outside diameter power 4 minus the inside diameter by 4, and tau is it has reached the yielding stress for the material, and R is basically the maximum shear stress in the torsion case appears at the periphery, so that is d by 2. So TH is basically, if I just simplify this, I'll be getting pi by 32, okay, into 2 into, this I can write t cube, because there's a d at the bottom also, so I can write 1 minus 1 by 16, and there's a by 2 again here, so this is 32, don't get mistaken, and this is tau yield. Okay, so this is, let this be 1. Now similarly, if I apply for the solid shaft, this is hollow shaft. Now if I apply for the solid shaft, the TS by J is pi by 32 into outside diameter by 4 to the power of 4, outside diameter same, and tau yield. So the only difference comes because the difference in J, and the radius, the outside periphery radius is T by 4 in both cases. So TS is basically pi by 32 d cube. Okay, so this 2 I have to write it above, sorry for that. Okay, and then this is 1 into tau yield. Okay, this is for 2. Now the ratio, what is asked? The ratio of the torque carrying capacity of the hollow to the shaft. So if I divide 1 by 2, I get TS by TH. The other things remains constant, these things remains constant, tau yield is constant, so it is basically 1 minus 1 by 16 or 15 by 16. So the answer is B. Thank you.